Well, thank you everyone for joining today. My name is Jeremias. I am part of the architecture team here at Whiteprompt. Today, I will be talking about AWS Infrastructure as Code tools, and we will ask the question, which one should I use? So first, let me give you a brief summary about OTTs. Online Tech Talks is a space where we share knowledge with our teammates. We could share anything that happened during the week or during our projects or some technology updates we want to share. So feel free to ask us if you want to present one. And we also upload the video later on to YouTube. We have a YouTube channel. So please subscribe and give us a like. So let's jump right in. Today, I've chosen some of the most used tools. There are some more, but I will focus on these ones. So I've chosen, obviously, AWS CloudFormation, AWS SAM, Serverless Framework, AWS CDK, and Terraform. This is an example architecture that I will be using during the presentation. So just for you to know, it will be an API gateway that is handled by a Lambda function, which later on will write items on DynamoDB. Let's start with CloudFormation. CloudFormation is a native AWS service, and every other tool that we will be seeing in this presentation compiles into CloudFormation. So it's kind of the parent of every AWS infrastructure as code tool. With CloudFormation, we can do everything we can do in the console and maybe more. And one really huge advantage is that it's every time updated with the latest AWS incorporations. So whenever a service appears in AWS or a feature, that feature or service will be added to CloudFormation instantly. Let's see a code example of CloudFormation. As I was mentioning, this will be the architecture with an API gateway, a Lambda, and a Dynamo table. So this is a standard CloudFormation template. I have chosen YAML, but you can choose JSON. It supports both. Same structure, just a different syntax. So here we have the list of resources from my template. We have a DynamoDB table with some properties that describe how that DynamoDB table is. Then my Lambda function, also with its properties. Here we know it's an Node.js Lambda function, and we have inline code here, which will be deployed inside the Lambda. Apart from the Lambda itself, we need to have a role that we should say that can be assumed by AWS Lambda service. So this is the assume role. And this role contains a policy which defines the permissions that the Lambda has when it is executed. So we are allowing this Lambda to put items in our Dynamo table that we previously declared. Then we have our API. And because CloudFormation has all the features, it's more complex to define things. So for example, for my API, I have to define my API, then the resource that will be /items, then the method for that resource that will be post, and we need to integrate this post method with the Lambda that we are declaring earlier. Lastly, we need to give API gateways permissions to invoke our Lambda function. So let's return to the presentation, and let's see about the pros and cons of CloudFormation. So ARIS, a native AWS service, is tightly integrated with AWS resources and service. As I said before, this means it has its last updates. As is the lower level of abstraction, we cannot go lower than this. Means we have more control on our infrastructure and on the settings of our infrastructure. It's a declarative language. You can use YAML or JSON. It supports rollback. When it fails, you are able to roll back the application to the prior state. And it supports drift detection that This is if someone changes something on your infrastructure differently than your template, it will detect that drifting and you can see which changes have been made and decide if you want to deploy it or not. Then about the cons, obviously it's limited to AWS services. As it's lower level of abstraction, that means more work because you have to go into all the details and all the settings that every service needs to have. It has a steeper learning curve. It's not easy to start using CloudFormation. It's not easy to get used to how CloudFormation behaves. And it has no native support for reusable modules. So it's every time you need to copy and paste and redefine everything again. You can import templates, obviously, but it's not as simple as the rest of the frameworks that we are going to see next. Now let's jump to AWS SAM. So SAM is a superset over CloudFormation, so it's backwards compatible. It offers simple declaration for serverless applications, and as I say, it's compatible with CloudFormation. And it includes a CLI which adds development and deploying capabilities, also local testing. So let's see the same architecture in SAM. As you see, it's pretty similar to CloudFormation. Same stuff, you can use YAML or JSON. And these 30 lines represent the same infrastructure that we have seen in CloudFormation with 83 lines. So we have a way to define the Dynamo table. This is exactly the same. And then we start using some specific types. For example, here I can say, this is my Lambda function. Here's the same, no JS. We have put here the code URI, but we could put also the inline Lambda code here. And we have inbuilt policies to help me give permission. So I can give write policy on Dynamo to this table in a simple manner. And also, I could declare events for this Lambda function. For example, I'm saying this Lambda function has an API /items with a post method. So this simplifies all the things that in CloudFormation I have to go into the details. Obviously, as it's more simple and it's more abstracted, I have less things I can configure. But for most use cases, this is enough. Let's talk about some pros. As it's built on CloudFormation and design, it's built on CloudFormation and is designed specifically for serverless. So I can add non-serverless stuff, but it will be the same as CloudFormation. It has simplified syntax. And I think it's more developer-oriented. Then the cons. Obviously, again, limited only to AWS services. And it's focused mostly on serverless applications. When you start using more traditional infrastructure, the tooling to deploy and the tooling for local testing stops being a pro. Now let's jump to CDK. AWS CDK, Cloud Development Kit, is a way to define infrastructure with the expressive powers of a programming language. It transforms, obviously, into CloudFormation after it's built, and it has Python, JavaScript, TypeScript, Java, .NET, and Go versions. This is because they are using a tool called JS II. It's a tool that lets you code in TypeScript and build applications in any of the other languages and makes an interface between the TypeScript execution and the other code. So let's see a code example of CDK. Here I have chosen JS as my language, and this is a standard CDK. Again, I am representing the same infrastructure that I represented on the other templates. So here I define my stack. As this is a coding language, it's similar to define an object. In fact, I am extending an object. I'm defining my constructor. And I define here, for example, my DynamoDB table. I set up my DynamoDB table there. I define my Lambda function. And I have this kind of helpers, like saying, okay, I want to grant write data permissions to this Lambda into this DynamoDB table. Also, I define here my API. my items resource, as I've been doing, and I add the method post. So it's, for developers, it's more readable, it's easier to understand, but it's a bit weird to say, okay, I'm writing code, but it's infrastructure. That's what seems weird, at least for me. So let's go back. Let's see pros and cons. So it supports multiple programming languages. So it's almost for everyone that knows some programming language. It has reusable constructs to create and share infrastructure components. That's something that some CloudFormation are missing. You can import components that other people have made with a simple import, and then you can extend them. As I said, it generates CloudFormation templates in the end. It's less complex, it's easier to create a complex infrastructures, and it includes a CLI for deployments. The cons: it requires familiarity with a supported programming language, obviously, is limited to AWS services, and is less complex. What that means is that the level of abstraction is increased, and when you start deploying things directly from CDK, you can start having problems with the CloudFormation deployment. And if you are not a CloudFormation expert, you need to start learning another thing. So it's like you will have to learn both things in the end. Now let's jump to Serverless Framework. It's a framework prepared to deploy serverless applications in any cloud. In any case, most people use it for AWS. Again, CDK is extendable. It has a big community which creates nice modules and plugins. So that makes you faster when you build big infrastructures. And it provides deployment and management of the infrastructure capabilities. Again, let's see the example. Serverless uses YAML, and here we can see we are declaring, as is multi-cloud, we need to declare our provider, obviously AWS in this case. We are adding to our Lambda permissions to put items on DynamoDB, which refers here to the specific table. We have here our function, which will have an API on the path/items method post again. And here we have our DynamoDB table definition. So pretty similar to the CDK and SAM, and simpler than CloudFormation in the three cases. No? Let's talk about pros and cons. As I said, it supports multiple cloud providers, not at the same time, but it supports if you need to code in another cloud provider and you are used to Serverless Framework. It has a large plugin ecosystem. I think that's the best pros for Serverless Framework. It has a simplified syntax for common serverless resources, even among different cloud providers. It has the application deployment and management inbuilt, and it has capabilities to do local testing with mock services and debugging of serverless applications. On the cons, it's more focused on serverless applications, so it's not that useful for traditional infrastructure, although you can use Serverless Framework for that. It requires a separate CLI tool, and it might not support all the native AWS features immediately when they are released. Lastly, I want to talk about Terraform. A Terraform is a tool to declare on human readable format infrastructure definitions. It is multi-cloud, it has deployment capabilities, and it will take care of driftings and unexpected changes. Again, let's see a code example on Terraform. This is HCL, the Terraform language, and this is an HCL file. I have the plugin installed in my VS Code so I can have color coding. So here we see we set up the provider, we say we'll have a DynamoDB table, we describe how our table is, we declare our Lambda function, same stuff, we define how we want it to be, we define the inline code here. We have our IAM role for this Lambda function, same thing that we did in CloudFormation, and the policy for this Lambda to put items in DynamoDB. Here we declare the API, we declare the items resource, the post method, the integration, the response, the permission for API gateway to invoke our Lambda, and we also have in here an output that says which is the API URL once our application is deployed. So it's pretty similar to CloudFormation, but here we have used every declaration of Terraform. If we start using modules, we could simplify things a lot. So pros and cons, it supports multiple cloud providers. It has a strong community and ecosystem, so we could find modules for everything. We have modules built for AWS that we can start importing and using, just passing the parameters that we want to change. It has a declarative language. It supports modules for reusability. You can declare your own modules that you will reuse among projects or among the same application. And it's a tool more DevOps-oriented than the dev-oriented. On the cons, it requires installing a separate CLI tool. This is one small comment. It can use a lot of disk space. The other day, I had an application that had 10 gigabytes for not that big application on importing modules and everything. That's because as Terraform is multi-cloud, it requires a lot of dependencies in order to work. It might not support all native AWS features immediately upon release. And as I said, it's not that dev-oriented. It's a tool more built for the DevOps team. So this is a small comparison. This is a small comparison chart. It's a summary of the things that we have mentioned. As we said, CloudFormation is native. CDK gives us support to multiple language. SAM is built for serverless over CloudFormation. Serverless Framework, multi-cloud, simplified syntax, and Terraform multi-cloud, strong community, reusable modules. So we have the cons, we have talked about that. And here we have a chart we can see for who is ideal each tool. So CloudFormations will be ideal if you need really in-depth control of the infrastructure. CDK is more convenient for users that want to write code in the same language and infrastructure in the same language they are building their application. So if you're SAM is similar to CloudFormation, but focused on serverless application. It provides local testing capabilities with Docker containers and deployment, debugging. So it's like CloudFormation, serverless, dev-oriented. Then Serverless Framework is similar to SAM in these aspects, but is targeting multiple cloud providers. It provides a simplified syntax, more simple even than SAM, and it has a really nice plugin ecosystem. And lastly, Terraform is multi-cloud support, strong community, and if you prefer to use reusable models, is one of the frameworks that has that capability. So the question, which one should use? Obviously, there is not a correct answer, but my advice would be choose wisely. The infrastructure is part of the application. We are constantly incorporating more infrastructure pieces to our applications. So the dev work ends when the application is up and running in production, not after committing and pushing. So the dev works include changing infrastructure every day. So we should ensure that devs have the tools they need to manage infrastructure on their behalf. Also, check on your project and your team. While each framework has its pros and cons, it's essential to evaluate your project requirements, team's expertise, and long-term strategy before making a decision. In some cases, it could be beneficial using a combination of these tools. So we can leverage each one's strengths for specific components within your infrastructure. So as I mentioned that, bonus, what if I use one than more? So I will talk about just one example that will be Terraform plus any or the others. So every other framework that we reviewed, even Terraform, exports to CloudFormation in the end. So one thing we could do is we can have Terraform managing the whole infrastructure and the deployment, and Terraform could import CloudFormation templates into its code. So we can connect our resources with inputs and outputs from our CloudFormation templates and Terraform, and we could delegate the deployment on Terraform. Let's see as an example, in this way, Terraform can import our templates and our resource namings, for example. And in this way, for example, in CloudFormation or SAM, we could output from our templates an ARN that we could share with Terraform. Same thing for CDK, same thing for Serverless Framework. And if we want to do it the other way around, here we have an example on how we could export an IAM role from Terraform and import it on SAM from Terraform. So this is all, and I'm expecting at least comments, or if you want to do some discussion about this, or any questions, so feel free to participate.
Yeah, hi, Ed, I have a quick question. You mentioned about importing via Terraform. You can import directly from the infrastructure from the cloud. Can the other options do the same thing? Serverless, SAM, CloudFormation, etc.
That's a good question. I can ensure you can do that on CloudFormation and SAM because they are compatible with CloudFormation templates. So if you could output any CloudFormation template from other frameworks, you could do that. Not sure on CDK. My guess is you could. I think you can. I don't want to say something that is not true, but my guess is that they might have some way, because you can use CDK in two ways. You could export the templates, or you could let CDK deploy them. If you export the templates, then you can use CloudFormation CLI to deploy them. So if you start using CloudFormation CLI, you can use any exported CloudFormation template from any service. And for Serverless Framework, I think that the most interesting part of using the framework is using the CLI. So if there is a way to import CloudFormation, I'm not exactly aware that that capability is there, but let's suppose it is. You could do the same. And that's it, at least for the tools I have here.
Okay, thank you.
Okay. Any other question, comment? Yes.
Hello. How are you? Which would be the best tool for CI/CD, for continuous integration, continuous delivery? Is there a better tool to apply this on AWS?
Let me ask you a question. For CI/CD on the infrastructure, or for CI/CD on the application?
Yes.
Oh, okay.
No.
Okay.
Yes, on the infrastructure. Yes.
Okay, got it. Yes. CI/CD on infrastructure is something I'm not in love with, because if you don't have a really nice control over the changes on the PRs, for example, that can lead on the application not working or stop working. So in my case, I prefer not to use CI over the infrastructure. But if you want to use it, you could use any of these. It's your choice. There is no correct or better, because every one of these, for example, if you use either CloudFormation or SAM, you could deploy with CloudFormation. If you use just SAM, you could deploy with SAM CLI. If you use Terraform, you could use Terraform CLI. CDK has its own CLI. Serverless has its own CLI. So on my experience, the best approach is, if you have a DevOps team and a DevOps team that chooses Terraform, let's try to deploy everything with Terraform and don't have two deployment phases or two deployment frameworks. And if we can import in Terraform everything, that's great. Because when you start having more than one deployment pipeline, let's say, or deployment stages, one stage can fail and the other not, and you can start having inconsistencies between the code. And as I was saying, applications are services, because today an application can be like 10 lambdas on 1,000 lambdas with 1,000 dynamos, and it's not like it was before. We have like a monolith application. The only thing that the infrastructure take care of is servers. So my advice there is try to have just one tool for deploying and try to integrate all the deployments in there. Then choose whichever it's easier or the one you like most. It's just a matter of trying each one, but each of these tools has really nice CLIs, and they work really flawlessly.
Thank you, Sharon.
Thank you, Mati.
Hey, I have a question. So we have those scenarios where we have like a Lambda code, where it's more the domain of a developer. But to deploy that kind of stuff, we also need DevOps work to have the resources in place and the permissions in place. Can you talk about these strategies to have a team of developers work in a Lambda space that is convenient to, not have trouble with the infra, like the both teams not stepping in each other's foots?
Okay, in that case, my suggestion or what I will choose is the development team using a tool that is more simple or more developer oriented, like either SAM or CDK or Serverless Framework, and use that for the dev environment so they can change everything on the fly, they can test things on the fly, and then on the actual deployment of the application into stage and production, integrate the output of those tools into, for example, Terraform code or CloudFormation code. So we can give like both the best of both worlds. No, the developers a simple tool to deploy, to develop, and the DevOps team a simple tool to deploy those resources. And if the developers can have either SAM, CDK, serverless, whichever you choose, they can add any type of resources they want. And the only point of contact with the DevOps work will be how we handle each other the variables. So for example, if we have a database on the Terraform or CloudFormation code that we want to access from the other templates, we just need to share ARNs and permissions. So we could give permission each other to access the different resources that we need from each side. But if I have to choose, I will choose the simpler for the developers in order to not have to learn a lot of stuff and have too many steps to create, for example, one Lambda, because as I was mentioning, applications nowadays are more services than code. So this will be more and more every day. We are going through a path that is less code, more services. So this will increase with time. I don't know if I have kind of answered.
For sure. Yeah, that makes sense. I did have one concern about this like cross stack referencing, because then you have one stack making a reference and the other stack making a reference back. So I guess from team to team, they need to arrange how to safely do these references.
Yes. It's not a straightforward solution, but it's what we have. It's what we have nowadays. And if I have to choose between SAM, CDK, serverless, I am a really big fan of SAM. That has included a new feature called Sync that lets you sync all your Lambda code that you're working with. And when you press save on your files, it uploads dynamically your Lambda code so you can test it right away in the cloud. It's just for dev. It's not for production ready because it uses the AWS CLI on the back. It's not IaC, let's say. It's just a hack. And apart from that, you also have the local testing that creates a Docker container that runs in a similar Lambda environment, your code. So if you are working with Lambdas and serverless stuff, my choice is SAM. Although Serverless Framework is really nice also. And what I like about Serverless Frameworks is the modules. When you start building things, it could be really helpful getting from someone else a structure for an application or for a problem that anyone has solved for you. CDK has the same stuff. So you should try and choose. The three of them are really nice.
Nice, thank you.
in the end, everything is CloudFormation. That's how AWS behaves. Okay. Any other question?
No questions. Thank you, Fede.
Thank you for joining today. Have a great Friday and a great weekend. And remember, follow us on YouTube and give us a like and subscribe.
Thank you. Bye-bye.
See you guys. Have a nice weekend.
Thank you.
Bye.
Bye.
See you.
And happy Labor Day.
Oh, happy